Welcome back. This is an Alex homework video on predicting the formula of ionic compounds with common polyatomic ions. So you're still practicing your polyatomic ions, I realize that, and it'll take a while to get them in your head. So in the meantime, you're going to be using them to make compounds with. You also are still practicing the fact that you need to use Roman numerals when naming anything from transition metals. So we've got two things here that you're going to have to be practicing at the same time. They're asking you to come up with at least 4 compounds that could be formed from these ions. So they've given you two cations, the iron 3 and the lead 4. Iron 3, it's named iron 3 because it's 3 plus. Lead 4 because it's 4 plus. And so I'll put those on the top. We'll just make a Punnett square again, same thing here. So I'm going to put, let's just put it on the side because we're going to make it on the side. So we'll put the lead 4 plus first. We'll put the iron 3 next. Then up here we'll put SO4 negative 2, and then the iodate IO3 negative 1. All right, so naming this would be lead 4. Naming this would be iron 3. This is sulfate, SO4 negative 2 is sulfate, and this is iodate. Okay, so when you put them together, this would be lead sulfate, lead iodate. So it's lead 4 sulfate, lead 4 iodate, iron 3 sulfate, and iron 3 iodate. So putting them together, remember you're going to have to get them to balance to where that they're the same charge. So I'm going to start with this. This is lead 4. I don't put the 4. I just know in my head that that's a positive 4. And then I have SO4. Problem is SO4 already has a subscript. And if I need more than one SO4 to balance, I'm going to need parentheses. Okay, so do I need more than one? This is positive 4, this is negative 2. I'm going to need 2 negative 2's to balance with a positive 4. So in order to do that, the entire thing has to be doubled. And I need parentheses around it because it's not just the oxygen that's getting doubled, but it's the entire anion that's getting doubled. So this would be lead sulfate, Pb parenthesis SO4 parenthesis subscript 2. And so likewise, we're just going to keep going. We've got lead, it's positive 4. Iodate is negative 1, so I'm going to need 4 of these to balance with a positive 4. So I'm going to need a parentheses, IO3, and then subscript 4. Okay, second line, I've got iron. Okay, I know it's iron 3, so it's positive 3. Ooh, I don't like this at all because I'm going to need a common denominator between 3 and 2. Ooh, I don't like this. Let me put it down. SO4. I know I'm going to need a subscript, so I'm going to go ahead and put this. But I'm going to need subscripts on both of these. So let's look at this just a second. If I have Fe, let me write this temporarily. SO4 negative 2. What is the common denominator between 3 and 2? It's 6. So what times 3 is 6? 2. I'm going to need a subscript 2 for the iron. What times 2 is 6? 3. And so since this is a polyatomic ion, I'm going to need parentheses around that. I'm going to need 3. The easy way to do it is that 2 coming down and this 3 coming down. That's how I do it. I just know that whatever the charge of the first is becomes the subscript of the second. Whatever the charge of the second is becomes the subscript of the first. So I've got a positive 3 here. It becomes 3. I've got a 2 here. It becomes 2. So it's going to be Fe2 parentheses SO4 parentheses subscript 3. And then the last one's easier. That's positive 3. Iodate, I need 3 of these because it's a -1. Oh, I don't use that. I don't use the negative. IO3, that's not a 10, it's IO3, and I need 3 of those to balance. Okay, so to answer the question then, give me 4 ionic compounds. The first one is going to be PbSO4 subscript 2, comma. The next one is going to be PbIO3 subscript 4, comma. Next one is going to be Fe2SO4 subscript 3, and the next one is FeIO3 subscript 3. Okay, looks very impressive if you can do something like this.